Let's break down this MATLAB code that calculates voltage drops in signal power. This code demonstrates voltage calculations over a resistor and signal power analysis. Let's start with the most common MATLAB commands you'll see everywhere. The clear command removes all variables from your workspace, giving you a fresh start. CLC clears the command window display, making your output easier to read. Close all open figure windows from previous runs. These three commands together are the standard way to start any MATLAB script. fprintf prints formatted text to the console, similar to printf in C or printf strings in Python. The syntax uses format specifiers like %s for strings and \n for new lines. Now let's look at how MATLAB handles variables and arrays. In MATLAB, you assign values using equals sign. The E notation means times 10 to the power, so 2e3 equals 2000. Scientific notation is built right into the language for convenience. The colon operator creates arrays. The syntax is start colon, step colon, end. This creates an array from 0.1 to 1000 in steps of 0.1, giving you 10,000 values. This creates an array like 0.1, 0.2, and so on up to 1000. MATLAB excels at array operations. Multiplying an array by a scalar multiplies every element. This converts microamperes to amperes by multiplying each element by 1 times 10 to the minus 6. MATLAB has built-in mathematical functions that work on arrays. The sqrt function computes square root. It works on both scalars and arrays element-wise. For AC signals, effective current equals peak current divided by square root of 2. When you divide an array by a scalar, MATLAB divides each element automatically. Log 10 computes the base 10 logarithm essential for decibel calculations. This converts voltage to decibels, using the formula 20 times log base 10 of the voltage ratio. MATLAB provides functions to analyze array data. The length function returns how many elements are in an array. Min finds the smallest value in an array. Max finds the largest value in an array. These functions help you quickly find minimum and maximum values in your data. MATLAB strength is creating visualizations with plotting functions. The figure command creates a new window for your plots. You can set properties like name and position using name value pairs. Subplot divides a figure into a grid of smaller plots. The syntax is subplot with number of rows, columns, and which plot you're creating. This creates a layout with 1 row and 2 columns for side-by-side plots. The plot function creates 2 D-line graphs from your data. You provide X and Y data, plus optional style strings and property value pairs. Hold on allows you to add multiple plots to the same axes. Hold off returns to normal mode. MATLAB offers extensive plot customization options. X label and Y label add text labels to your axes. Title adds a title at the top of your plot. Grid on displays grid lines to help read values. Grid minor adds finer grid lines between major divisions. Xlim and Ylim control the visible range of your axes. You provide a 2-element array with minimum and maximum values. Now for some less common but useful plotting features. X-line and Y-line draw vertical or horizontal reference lines. You can set the line style and transparency using alpha values between 0 and 1. The text function places text at specific coordinates on your plot. You specify X and Y coordinates, the text string, and optional formatting properties. Reference lines help mark important values on your plots. Sprintf creates formatted strings, similar to fprintf, but returns the string instead of printing it. Format specifiers like %.2f control decimal places in your output. Finally, let's look at specialized functions used in this code. num2eng is a custom function that formats numbers in engineering notation with SI prefixes. It takes multiple Boolean flags to control formatting, like showing units or using prefixes. Important: num2eng is not built into MATLAB. It's a custom function that must be in your path. The alpha property sets transparency for plot elements, with values from 0 for invisible to 1 for opaque. Marker face color sets the fill color for plot markers like circles or squares. Line width sets how thick lines appear in your plots, measured in points. Let's summarize the key MATLAB concepts we covered. MATLAB automatically applies operations to entire arrays, making code concise and fast. The colon operator is your go-to tool for creating evenly spaced data arrays. Most MATLAB functions accept optional property value pairs for customization. Format specifiers like %s, %d, and %f control how data appears in text output.